So lesson 1.1, what you will learn, solve linear equations using addition and solving linear equations using multiplication. Use linear equations to solve. These are things that you've done before, and so this is just a great place for us to start. An equation is a statement to express equal sign, and a linear equation is in one variable equation that can be ax plus b equals 0. B are constants. A does not equal 0. When you solve an equation, you use the properties of real numbers to find a solution, which is a value that makes the equation true. A couple things to think about is when you look at a definition like this, it's interesting because it says linear equation in one variable is an equation that can be ax plus b equals 0, where a and b are constants. A is not equal to 0. If a equals 0, we have 0x plus b equals 0. And what they're saying then is that the only thing you'd have is b equals 0. But b doesn't actually have to be 0. It says that right there. So what we might have is we might actually have something that's untrue. It's really kind of a you'd have a constant equals 0, and so really if b equals 0, you got this thing right here that's called tautology, but it doesn't mean anything. It's just like, hey, here 0 equals 0, and you're like, duh. Whereas if b equals anything else, like say it says 1, then that's 1 equals 0, and you know that that is a contradiction. So that's the kind of thing that we're looking at with this definition. When you stop and look at definitions, stop and think about what it means if a is 0, or what it means for a to not be 0, what it means for a to be 0. These are important things to consider. Play around with math. Inverse operations are two operations that undo each other, such as addition and subtraction. When you perform the same inverse operation on each side of the equation, you produce an equivalent equation. Equivalent equations are equations that have the same solution. I'll try to talk about this as problems. It's one of those things that gets lost. Since this is your second go through on equations, it stick a little bit better. Addition, subtraction, substitution properties of equations. So if a equals b, then I can add some value c to both sides and still have a statement. Likewise, I could subtract c from both sides and still have some sort of true statement. And then if a equals b, then a can be substituted for b or b for a in any equation or expression. These things are important for various reasons that we'll see. So if we look here, if you were in my class, what I would do with these two equations is I would stop and I'd say, hey, what is holding the 3 together with the x? It's a subtraction sign. Of course, what's the inverse of subtraction? Addition. Now, a couple things. I want to show you a couple things to think about. Number one, let's pretend like we actually did know that x. If we knew that this answer was 7, then we would just subtract the 2. But because we don't know it, we say, hey, what's the inverse? Now, typically, how I handle this is I write down plus sides. Now, if you look back up here, addition property of equality, what they would probably do is they would go x minus 3 and then negative 5 here, and then do a plus 3 here, plus here. Either method is I like the vertical method versus the horizontal method. The vertical method is really kind of a shortcut if you so I'm going to go x equals negative 5 plus 3 is 2. It also says check your answer, and it says justify each step. Justify each step, this is the addition property. I'm not going to actually ask that you do that, but just note that at some point there are some problems that it says check your answers on. If you look here, it's this to check your answer, we substitute. You know that x equals negative 2. And by the substitution property, we could say, hey, then that x can be replaced with 2. So we have negative 2 plus negative 3. Sorry, negative 2 minus 3, which is actually negative 2 plus negative 3. And negative 2 plus negative 3 is 5. So 5 equals. Doing this again, here we have addition. The inverse of addition is subtraction. And so what we're going to do then is we're going to subtract 2.8 sides. And doing so, again, same signs, add and keep, but these are different signs, so we'll subtract. If you're going to subtract by hand, remember that the larger number, the value that's bigger than, I should say it this way, the value that has a greater magnitude is to go on top of opposite signs, because we're going to subtract these two. So the only way to subtract safely is to write larger, bigger magnitude on top. 2.8 is bigger than 9, so 18 minus 9 is 9. You drop the decimal 9, and this is a negative, so we keep the sign of larger value that's magnitude. So we get negative 1.9. Check our answer here. We go back through here. We go 0.9 equals negative 1.9 plus 2.8. And 2.8 minus 9, checking. Just because it's good to do. I know it's like, look, I know it's going to be, get it. But they ask you to check. It's just good to go back through and check. So there we go. Let's do this. Let's see what the next example is. Solving linear equations by multiplying or dividing. So just as addition and subtraction are inverse operations, multiplication or division are also inverse operations. This leads me to stop. So here's my operations. Here's my inverses. Plus, minus, minus, plus, times, divide, divide, times. And don't forget, if you square a value, the square root of that, or if you have a square root, squaring. So just keep those in mind. Let's see. So if A equals B, then A times C equals B times C, where C doesn't equal 0. Yeah, this one's kind of interesting, because if we had two values here, we have A equals B, and the problem is it comes down to truth, is that when you multiply by 0, you're getting, and so if if C equals 0, you're getting both sides to just equal 0. And again, although that's true, it does lead to some questions about, like, hey, if these were variables, what? But it does say that they're already equal. It's just weird to. I'm just thinking about this, where it's just weird to multiply both sides by 0 later. I guess that's because it's not safe. Likewise, we never divide by 0, so that's why we divide both sides by C 0. I'm going to think that some more about this. Because what I'm really thinking is that if you had x plus equals 7, and you decided to multiply both sides of the equation by 0, now you get something that's absolutely true, and x plus 3 is a real number, and it's going to equal 7 if we could figure out what x is, but now you got 0 equals 0, which doesn't let you solve for x. I think that's really the problem. So here we're going to solve each equation. I am going to forego the actual step justifying work for undoing division, so that's by multiplication. I want you to see this negative sign. Students get confused all the time about the fact that this negative sign, it can go up here or it can go down here. It just can't. So we've got n equals -5 times -3, or equals, sorry, n over -5 equals -3. Multiply both sides by 5. -3 times -5 is 15. You can check this out. 15 divided by 5 is 3, and is negative, so that means that this one's here just to make you freak out for a moment, but as you've already done some of this before, dealt with circles, you know that you're just dividing by pi to undo the multiplication. And so x equals 2. This last one's just a decimal. So we divide both sides by 3. So z. Well, if 52 divided by 13 is 4, then 5.2 divided by 1 is also 4. More to go. Okay, solving real-life problems. This is one of the things that we are going to be working on throughout. Understand the problem, what's the unknown, what's the information given, what is being asked. Make a plan. This plan might involve problem-solving strategies shown on the page. Carry out the plan, check that each step is correct. Look back, examine your solution, check that your solution makes sense. This is huge, the original statement of the problem. We're going to come across some problems that have multiple answers, and there's only going to be one that's correct. It's the only one that makes sense. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.2 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So you want an average speed. So to the nearest hundredth per second. So this is a little unit analysis. Meter per second. It tells us what to do. If you think about average means that we're going to typically find some sort of sum and divide it by some sort of number. Well, the sum that we have is the 200-meter dash. And if we look here, it's a meter, so top 100 divided by time of 15.2 seconds. Now, I don't feel overly sadistic, so I'm going to go ahead and calculate, because I really like that. So 200 divided by 19.32. And so notice I have an equal sign here, but this came out as a decimal. So, and it says nearest hundredth of a meter per second. So I'm going to say, instead say approximately. And hundredth is the second place in the decimals. So it's 10.35. We don't round that up to 6. 1 does not push the 5 upward. And we're also going to label our answer. Here's second. So we're saying that E covers 10.35 meters in 1 second. And so just thinking that through here for a moment, 10.35 meters, that's roughly 10. And 19.32 seconds is roughly 20 seconds. And so we're going to say that 10 times 20 is 200 meters. So our answer makes sense. One more here. Common problem-solving strategies. Use a verbal model, draw a diagram, write an equation, look for a pattern, work backward, guess, check, and revise. Sketch a graph or a number line, make a table, make a list, and charts. Those are typical problem-solving strategies that you'll need to try. On January 22nd, 1943, temperature in Spearfish, South Dakota fell from 4 degrees at 9 a.m. to -4 Fahrenheit degrees at 9:27 a.m. Wow. How many degrees did the temperature fall? Okay. So I'm going to use a verbal model here. Temp at 9 a.m. minus temperature change is going to equal temp at 9:07. So this is just a verbal model to help you see how a verbal model works. I could draw a number line. I could have sat here and gone 9 a.m., temperatures here, 9:27, temperatures here, and then get a number line where I can go here, and I can see that I want to find the distance. However, with this being an algebra question, although this is a valid way to solve this being an algebra question, I think that a verbal model is probably more appropriate. So 54 is the temperature at a.m. minus some unspecified temperature change is going to equal 4. So we're going to subtract 54 from both sides. That's going to give us negative x equals, this is going to be negative 58. Now, what we know, a couple things we know. We know that we could still undo this multiplication by -1 right here, or we could use some common sense. If the opposite of x is the opposite of 58, then x is 58. But if you don't like that, you can divide both sides by -1, and you get the answer that way. Now, a couple things about the answer. We want to label it. We want to explain the temp fell 58 degrees. So that's how much it fell. Say the temperature changed by -50. So that would put that negative if you want. Likewise, I will say this. You could have, if you were savvy enough, you could have said things like, I want change in temperature, so that's -54 minus -4 temperature. You could have said that the temperature change plus -4 would equal 54 because the starting total. You could do all sorts of things to create just solve the problem in general. But it doesn't really matter which way you solve it, just as long as you do to solve it. So you have some worksheets that they give you. The first sheet gives you some problems of just regular practice. I would really like you to do that with a calculator. Sorry, I said that poorly. You should not use a calculator on the first page. In fact, the second page, you shouldn't use a calculator on either, I don't think. The second page only has 3 problems down at the bottom. The first practice page that you get, it has a bunch of problems there. They're just solving step equations all the way through. Take time. There's a worksheet as well that match up. There's a little puzzle. Check your work. So overall, I don't think that today's lesson is overly difficult, but I do think that it gets us back into the swing of things